Alright, so for this problem, it's a pretty easy problem, but it's pretty cool. Pretty cool what's happening. So this is a picture, alright, of what's going on. See, we have our magnetic field going into the board, into the screen. We don't know what that is yet exactly, but we'll find that out. Then we have our circuit here with our light bulb in there. Yay, light bulb. Alright, so with that radius R, and it's going to the right across the magnetic field. So we're given the voltage it needs to be, and we have the resistance of the light bulb, and we're assuming that there's essentially no resistance in the wire. So we'll use Ohm's law to figure out the current through the circuit. So 1.5 volts divided by 3.5 gives us a current of 0.4286 amps. So since the magnetic field is going into the screen, the current around the loop would be going in a clockwise direction. So now that we know the current, we can go ahead and plug that into the equation for magnetic force. Now, magnetic force equation is the current times the change in position cross B. Now, it said that the circuit is moving a radius length. So the radius is 0.08 meters times the current and times B. And we're given that the magnetic force is 0.0583. So we do some math here, multiply these two, then divide this by those two, and we get that the magnetic field is 1.7 Tesla. So now that we know that, we can use this equation for potential here, where potential is equal to the velocity times the magnetic field times the length, well, radius in this case. So we know the magnetic field now, and we know the radius, so we can multiply those two together, and we know the voltage is 1.5, so we can divide the magnetic field times the length, well, we divide the voltage by the magnetic field times the length, and we find the velocity needed to generate that voltage of 1.5 to be 11.029 meters per second. So that's pretty cool, because that means if you can pull this circuit through this uniform magnetic field here, if you pull it at 11.029 meters per second for a distance of 0.08 meters, it would create the same amount of potential difference that a battery would create, a standard battery. So that's pretty cool. I thought it was a cool problem.